Now let us look into various expressions of concentration, how they are related to each other and how we can adopt them how we can adopt them while solving problems. Firstly, relation between molarity and molality. The first relation is molarity is equal to molality into density. This relation is applicable only for dilute solution and if the density of the solvent is given. Apart from that, molarity is equal to molality. This expression can be used if water is a solvent and density is 1 gram per centimeter cube or 1 kg per dm cube. This relation is only for an aqueous solution. Moving further, the density of a solution, if it is given, then molality and molarity can be related as molality is equal to molarity divided by 1000 into density minus molarity into M2 stands for molecular mass of solute, or it can be simply written as 1 by molality is equal to density by molality minus molecular mass of solute divided by 1000. Now let us look at the expressions of relation between molality and mole fraction or molarity and the mole fraction, and they are molality is equal to 1000 into chi2, where chi2 represents the mole fraction of solute, divided by chi1 into m1, where chi1 represents the mole fraction of solvent. Apart from that, relation between molarity and mole fraction is given as molarity is equal to 1000 into density into chi2, which is the mole fraction of solute, divided by mole fraction of solvent into m1 plus mole fraction of solute into m2, where m2 represents where m1 stands for molecular mass of solvent and M2 stands for molecular mass of solute. So these are the various representation of concentration terms. Now let us take up some examples based on the concentration. Firstly, the volume of ethyl alcohol whose density is 1.15 gram per cc that has to be added to prepare 100 cc of 0.5 molar ethyl alcohol solution in water is, the given options are option A 1.15 cc, option B 2 cc, option C 2.15 cc and option D as 2.30 cc. Now let us consider the given data from the above question. Here we have density of the solution as 1.15 gram per cc. Let us write down that 1.15 gram per cc, and the volume of the solution is given as 100 cc. V is equal to 100 cc, and one more data is it is 0.5 molar, that means molarity is 0.5 molar, and what we are supposed to find out is the volume of ethyl alcohol that has to be added. From the given data, it is evident that we have to make use of molarity relation, and we already know that molarity is given as mass of solute divided by molecular mass of solute, that is nothing but number of moles of solute, into 1000 divided by volume of solution. Firstly, let us find out the molecular mass of solute. In order to find the molecular mass of solute, the solute here is ethyl alcohol, whose formula is C2H5OH. So, in order to find the molecular mass, we need to consider the number of atom and its atomic mass. So, the atomic weight of carbon is 12 and it is multiplied by 2 because there are 2 carbon atoms. Similarly, 5 into 1 plus 16 into 1 plus 1. So, when we total this, we get 46 gram per mole as the value. Now, on substituting these values, we get 0.5 molar is equal to mass of the ethyl alcohol into 1000 divided by 46 into 100. Upon simplification, we get mass of the solute, that is ethyl alcohol, as 2.3 gram. So, here we have the mass of the solute as 2.3 gram. Now, in order to find the volume, we have to make use of density relation, and it is given as volume is equal to mass of the solute divided by density of the solution, and the mass of solute we have obtained as 2.3 gram and the density is already given 1.15 gram per cc. Therefore, volume is 2 cc. Therefore, the right option is option B. Six 6.02 into 10 to the power 20 molecules of urea are present in 100 ml of its solution. The concentration of solution is, and the given options are A 0.02 molar, B 0.01 molar, C 0.001 molar and option D as 0.1 molar. Now, let us consider the given information from the question. Here we have 6.02 into 10 to the power 20 molecules of urea. So, given the number of molecules of urea as 6.02 into 10 to the power 20. Apart from this, we also have volume of the solution, which is 100 ml. Then, the unknown parameter here is the concentration of the solution. From the option, it is evident that the options are mentioned with the unit molarity. So, the concentration term here is molarity. Now, let us solve the problem. We already have volume of the solution as 100 ml. Since it is molarity, it is nothing but number of moles of solute in 1 liter, we have to divide this by 1000 and we get 0.1 liter. Therefore, the number of moles of urea is nothing but 6.02 into 10 to the power 20 divided by Avogadro number 6.02 into 10 to the power 23, which is equal to 1 into 10 to the power minus 3 mole. Thus, the concentration of urea is 1 into 10 to the power minus 3 divided by 0.1, which is equal to 1 into 10 to the power minus 2 mole per liter, or 0.01 molar, and hence the right option is option B.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.